Okay, let's look at another problem. This one says you and a friend are doing the laundry when you unload the dryer and the discussion comes around to static electricity. Your friend wants to get some ideas of the amount of charge that causes static clean. You immediately take two empty soda cans, which each have a mass of 120 grams, from the recycling bin. You tie the cans to the two ends of a string, one to each end, and hang the center of the string over a nail sticking out of the wall. Each can now hangs straight down 30 centimeters from the nail. You take your flannel shirt from the dryer and touch it to the cans, which are touching each other. The cans move apart until they hang stationary at an angle of 10 degrees from the vertical. Assuming that there are equal amounts of charge on each can, you now calculate the amount of charge transferred from the shirts. Okay, we're going to start our problem by drawing our picture. Okay, so I've drawn the two cans, which are hanging a length of 30 centimeters from the nail and at an angle of 10 degrees. Each can has a mass of 120, should be grams, not milligrams, should be grams. So the question is, what is the amount of charge on the cans? This is the question that I'm going to try to answer in this problem. My answer should be in units of coulombs. I'm going to use the concept of electric force, or Coulomb's law, because I want to know how much charge is on the cans. And Coulomb's law deals with point charges and the forces of these two charges. Okay, so in this case, I'm going to draw a force vector diagram because I'm dealing with forces here, and it looks similar to some problems that I've done before. So I'm going to draw all the forces acting on one of the particular cans, putting the can at the center of the axis, and I know that there's an electric force that's a repulsive force because it's causing the two cans to move away from each other, which also tells me that the charge is either going to be both positive or both negative. Since there's a string attached, I know there's a tension force, and it has an angle of 10 degrees from the vertical. And I also have the weight of these cans pointing down, which is going to be F is equal to mg. G is going to be acceleration due to gravity. So this is my force vector diagram. I also know that the distance, if I using Coulomb's law, I need to know the straight line distance between the two objects, which is going to be what I've drawn here in case of R. But what this now looks like is two right triangles. So if I just look at the one triangle, I know that L, which is the length, which I know is 30, and I know the angle theta, so I can find the opposite side, which is going to be L sine theta. So the other side, which I'll call R, is going to be equal to R1, is going to be equal to L sine theta. Since there's two lengths, I double that, so R is going to be equal to 2 L sine theta. So using my trig functions, I can find out the distance, straight line distance between those two cans is going to be equal to 2 times L, which is the length of the string, times sine theta, theta being the 10 degrees. Okay, write down my knowns. I know the mass, I know the length of the string, I know theta, and K is a constant that is given. I know my unknown is going to be Q1 or Q2, but this is what I'm going to be looking for. So the relationship is going to be F is equal to K, the magnitude of Q1 to the magnitude of Q2, divided by R squared. I'm also going to use Newton's second law, which allowed me to say F is equal to m times g, which will allow me to calculate the weight of the can. I'm also going to use Newton's first law because they tell me that the cans are stationary. Stationary means that they're not moving. Newton's first law deals with balance forces, which means an object is either moving at a constant velocity or it's not moving at all. And I have the second case where it's not moving at all, so I can use Newton's first law also. So second law says F is equal to W is equal to mg. G, again, is the acceleration due to gravity. It's a constant. And then Newton's first law tells me the sum of the forces is equal to 0, meaning there's no net force acting on an object causing it to accelerate. Okay, so I've drawn my picture, I've identified my question, I've written down the concepts I'm going to use, I've even drawn a force vector diagram, and I wrote down my known and unknowns. So now I'm ready to start my planning. So I'm going to plan the solution. To plan the solution, I always start with the equation, which will give me my answer. And in this case, it will be Coulomb's law. So I know Q1 is equal to Q2. I've already established in the problem that the two cans have the same charge on them and also the same sign. So I can rewrite Coulomb's law as F equal to K Q squared over R squared. Now I'm looking for Q. Q is the variable we're looking for. So I can solve this for Q. So when I solve for Q, I get the square root of quantity F R squared over K, where F of E is the force, the electrical force on those two cans. This is the force that is causing the cans to spread away from each other. I can bring R out, so I get R times F of E over K. So what's unknown is the electric force in R. K is a constant, and I'm looking for Q, so that's fine. So how do I find the electric force? I'm going to now go back to my 152 knowledge and say that the sum of the forces is equal to 0, which is Newton's law. And looking at my free body diagram, I'm going to sum all the forces, and in this case, X. So if I sum the forces in X, I get the electric force minus T sine theta, which is the tension force in the minus X direction, is going to be equal to 0. So the sum of the forces in X have to be equal to 0. So this is the relationship that I get. Now I can solve this for F of E because this is the value that I'm looking for. This was my unknown in the line earlier. So F of E is equal to T sine theta. But now I don't know what T is, which is the tension and the strain that this can is attached to. So now what I can do is do the sum of the forces in Y, because the sum of the forces in Y have to be equal to 0 also, in order for these cans to be stationary. The forces in Y is going to be T cosine theta in a positive Y direction, and minus mg, which is the weight of the can in the negative direction, and they'll be equal to 0. Again, obeying Newton's first law. So I'm going to solve for T. In this case now, T is going to be equal to mg over cosine theta. Now in this equation, I know m, the mass, I know g, I know I know the cosine of my angle, which is, the angle is 10. So, now that I have T, I can solve T, and I can go back up to the equation Fe, because now I know T, I know theta, so I can find F of E. Now that I know that, I can go back up to the other equation of previously and plug in the electric force. And this is the equation that I'm trying to solve, because if I can solve this equation, I know what Q is equal to, which then answers the question on the previous page. And we said earlier that R was equal to 2L sine theta, so I now have R. So my unknowns for the equation that is starred, asterisk here, I didn't know R and I didn't know F. So now I know R and F. So now I can execute my plan. Executing my plan means I'm going to plug in the actual values, numerical values, and solve. So I plug in for R, I can actually plug in t, the value for t, which is mg over cosine theta. Sine over cosine gives me tangent, so I can just solve for mg tangent theta. After I get f of e, I plug that in and solve for q. And my value will be off some because I use kilograms instead of grams. Use milligrams instead of grams. Okay? But your value should be somewhere around here.